Let G be the centroid of a triangle ABC and S be any point in the plane of the triangle. Show that SA vector plus SB vector plus SC vector equals 3 times the vector SG. Okay, let's try to understand the problem graphically first. So here we have a triangle ABC. Now AD, BE and CF are the medians of the triangle which meet at the common point G. G is the centroid of the triangle. Now we're going to consider another point S lying on the plane of the triangle. So our goal will be to show that if we join SA vector, point S and point A, S and B, S and C, then the sum of these three vectors must be equals to 3 times the vector SG. Now we'll be defining the position vector of the vertex A, B and C. So for this, we're going to consider a point O, which is going to be the origin of some coordinate system. Now with respect to this origin O, we can define the position vector of the vertex A as A vector. Suppose that position vector of the vertex B is B vector and the position vector of vertex C is C vector. That means let OA vector thus be equals to A vector, OB vector let it be equals to B vector, and OC vector let it be equals to C vector. And we'll also consider the position vector of the point S to be denoted by the vector S. Also, by definition, we know that the position vector of the centroid of the triangle ABC, that is OG vector, will be given by the sum of the position vector of the three vertices, that's A vector plus B vector plus C vector, whole divided by 3. We're going to label this as number 1. We're going to come to this in a moment. Now, let's start with the left-hand side of our problem. So on the left-hand side, we have SA vector added to SB vector plus SC vector. Now, in terms of the position vector, we can define SA vector as OA vector minus OS vector. Then SB vector can be expressed as OB vector minus OS vector. And SC vector can be expressed in terms of the position vector as OC vector minus OS vector. Now, we can use OA vector as A vector. So we have A vector minus S vector added to B vector minus S vector plus C vector minus S vector, which gives us A vector plus B vector plus C vector. This is from here we're going to subtract negative 3S vector. Now we can rewrite A vector plus B vector plus C vector as 3 times A vector plus B vector plus C vector. Now 3 is an extra factor that we're multiplying it with, so we need to divide it by 3 also. So minus 3S vector. However, A vector, B vector plus C vector divided by 3, this is nothing but the position vector of the centroid. So that means we have 3 times OG vector minus 3S vector. So S vector is simply OS vector. Now what we can do, take 3 as the common factor. So we have OG vector minus OS vector. So when we combine that, this is simply going to be SG vector, which is the expression on the right hand side. So thus we have successfully showed that SA vector plus SB vector plus SC vector, that thus becomes equals to 3 times the vector SG, hence proved.